Hi, let us continue with our demo session where we looked at user-defined data types and some basics of lists and type classes. So what I'll do in this session is to take up two slightly more involved examples just to illustrate the whole process of programming. Okay, one of the ways to learn programming is to actually take up a slightly non-trivial task and try to develop a solution from scratch. So for all the programs I have shown you are programs that I have already written, and I am just showing you the programs and I am discussing them. But here I will start with the statement of a problem, and we will try to develop a solution step by step. Okay, and hopefully these are I'll look at two problems. Hopefully they are interesting. So I have this GHCA session. Here is the first problem. This is a problem of a slightly mathematical nature. So let's just start to introduce the problem. We'll just play around a little with in GHCI, and that will explain what the problem is. Suppose you start with a 4-digit number. Let me start with something random, 5829, let us say. Okay, that's a 4-digit number. Now, what do I want of this 4-digit number? It could be at most 4 digits also. It could be 300 or some such. The only condition that I want is it should have at most 4 digits. Not all digits should be the same. Okay, at least one digit must be different from the other digits. This is the only criterion that I have. So let's go back to our 5829. Yes, we have this. So now what I want to do with this is the following: order the digits in descending order. That will give me 9852. Then order the digits in ascending order, 2589. So I subtract the first from the second from the first. I'll get 7263. Now what do? Once again do the same thing. Order the digits in ascending order, 2367. Order them in descending order. Order the digits in descending order, 7632. Order them in ascending order, 2367. Subtract one from the other. I'll get 5265. Let's repeat this again. I have 6552 minus 2556. This gives me 3996. This gives me 3996. From 3996, what do? 9963, because that is the descending order of the digits, minus 3699, that is the ascending order of the digits. That gives me 6264. Once again I repeat it. 6642 minus 2466 gives me 4176. Now 4176 ordered in descending order is 7641. Ordered in ascending order is 1467, and the result is 6174. Now, if I take 6174 and order it in descending order, it will once again be 7641. And if I subtract it from, and if I subtract 1467 from it, I'll once again get 6174. So at this point, I'll get the same number again and again and again. So what is it that I want to do? I want to write a program that, given a number like 5829, should produce the whole list. Which list? The original number 5829, the number you got by subtracting the descending order of digits, the ascending order of digits from the descending order of digits, which is this number here, 7263. Yeah, so 7263 followed by 5265, followed by 3996, followed by 6264, followed by 4176, followed by 6174. At this point it should stop because the same number keeps repeating. Okay, this is what I want to do. I want to write a program that, if I take 5829 as input, should give me this whole list as output. To take the other example, if I start with 300 in its descending order of digits is actually, so remember I said you should consider it as a 4-digit number. So 300 should be considered as 0300. So then in descending order, the 4 digits will actually become 3000. Okay, 3000 minus 0003 is 2997. Now 2997 in descending order is 9972 minus 2799, 7173. Now this is 7731 minus 1377. This is 6354. Now 6354 in descending order is 6543 minus 3456. Yeah, 3087. Once again, 8730 minus 0387, which is just 387, is 8343. Now 8433 minus 3348, 5085. 8550 minus 558 is 7992. 9972 minus 2799, and it goes on like this. Now you might wonder whether this procedure will continue forever like this. Maybe I made a mistake somewhere, but we should take a look. So here you see that 7173 repeats. Yeah, let's work this out. Okay, so we would like a program that produces this list. Now we have to figure out what happens if the process goes on forever. We'll see. So at least in the first example, I said that we should stop if the same number repeats immediately in the next step. Okay, so let's try to write this up as a program. Since we are very unimaginative, we'll just call this function f. F is a function that takes an integer and produces a list of integers. Okay, and what should f do? Let's assume that it is that it has already been sanitized. F of n equals, so you have to somehow compute the next number in the sequence. If next number of n, so let nn equal next number of n in. Okay, we have to do, if the numbers are the same, then we have to stop. If the numbers are different, then we have to do something. Okay, we'll come to that in a minute, but first let's figure out how to write this next number function. And ideally you would have to write a function where you would first check whether n is of the required format. Okay, what is the required format? It should have at most 4 digits. Not all 4 digits are the same. Okay, we should first check that. If it fails that condition, we should flag an error. Only if it passes that condition, we should actually start to look at the next number in the sequence. But what we will do is, we'll combine these two procedures in the same. Next number will first check if the number is correct. If so, it will produce the next number, otherwise it will give a 0. Okay, so that so we could do it this way, or we could just do once, we could test whether the number is of the required format. Okay, maybe we'll do it that way first. Okay, so check input, let's call this. Okay, it's a function from int to bool. What is it that you want to check? Okay, check input. Firstly, if it's negative or if it has more than 4 digits, you are going to reject the number. Okay, if n less than or equal to 0, if it's even 0 is not accepted, because 0 stretched to 4 digits is 0 0 0 0. All 4 digits are the same. Okay, we don't want that. If n is less than or equal to 0, or n is greater than or equal to 10,000, then or suppose both these conditions pass, meaning that n is greater than 0 and n is less than 10,000, then what you need to do is to extract the digits. Okay, so we will have to do that. Okay, so let's see how to extract the digits. Okay, so this is one function built on top of another function, etc. So as we require more functions, we are trying to generate them. So let me comment this out for the moment, and let's go to extracting the digits from a number. Okay, we want to just extract 4 digits. Let's assume that by the time we come here, we have already passed the number is already passed the 2 tests, that n is greater than 0 and n is less than 10,000. Okay. Now, extract digit means, how do you extract the digits? You first divide by 1000 and then take the quotient, that is the first digit. The remainder you will again process by dividing it by 100. The quotient is the next digit. You will again process it by dividing it by 10 and the quotient is the next digit. Finally, whatever remains is the last digit. So rather than do it, it's an iterative procedure, it's an iterative process, it's a recursive process. Okay, so extract digits n equals, let's say, go n 1000. I'll have an auxiliary function where I have the original number and the divisor in, let's define go now, where I should say, go m is my number, let's say, and d is my divisor. Okay, you will see that I will also modify the divisor. First I have to divide by 1000, then I will divide by 100, then by 10, then by 1, and then the divisor itself, the divisor will keep shrinking. If the divisor ever becomes 0, I don't ever want to divide by 0. So if the divisor is 0, I will stop. Then I will return the empty list by the time I have reached the end of this whole process. Else, go of quotient, I am shrinking the divisor each time. So quotient followed by go of remainder and d div 10. What is quotient and remainder? Is nothing but m div mod 10, m div mod d. Okay, so this is my extract digits routine. Let's check if this works correctly. Let's go to GHCI. Let's load demo programs. Somewhere there is an issue. Sorry, there were a couple of silly errors. I have now fixed them. So this whole thing loads now. So now let's do extract extract digits of 3000. Let's say we will get the list 3000. Extract digits of 3. Let's say you will get 0003. 30 will give you 0030. 4000, whatever, will give you 4000. 2894 will give you 2894. Okay, fine. So this works. So let's get back. Now I have a way to extract digits and make it into a list. Now what does check input have to do? Check input has to extract the digits, and once it has extracted the digits, it should check whether it is not the case that all digits are the same. Okay, what does that mean? That means that if you have 4 digits, then the rest of the digits are the same as the first digit. Okay, you don't want that to happen, and for that we use the following: or any not equal to d of ds Okay, so what is any? I'll explain it in a minute. So there are two functions. Let's all type. Let's look at the type of all and any. Okay, this is a function which takes a predicate, which is a function of type a arrow bool, and a list of values of type a, and it will produce a bool. What is the behavior? If every value in the list satisfies the predicate, then it will return true, otherwise it will return false. For instance, all even 2, 4, dot dot 10 will give you true. All even 2 dot dot 10 will give you false, because 2, 3 is not even. Okay. Similarly, any is something, any is also of the same type. Yeah. So if any one of the elements in the list satisfies the predicate, then it will return true, otherwise it will return false. So let's try this with the same kind of list. Any odd 2, 4 dot dot 8 should return false. 2, 4 dot dot 10 should return false, because all numbers in the list are even, no number is odd. On the other hand, any odd of 2 dot dot 10 should return true, because 3 itself is odd, right? So this is the point about any and odd. So what you are doing is, in the program, you are extracting the digits of n, let's call it d followed by d's, and you are checking whether anything in d's is unequal to d, right? So that means that at least 2 digits are different from each other, and you are done. Okay, so this is what my check input routine should do. Okay, fine. So let's get back to this f. At least we have one thing out of the way, and since we need to do multiple conditions, let us switch to a guarded command style rather than if then else, because if then else would mean that you would have to write too many nested if then else's. Okay, so f of n, if not check input of n, so then you say input is not of the proper format. Okay, fine. Else there are two conditions. You now is when you actually do the next number. Okay, next number. There are two conditions. Next number equals n means that you have to stop. You stop by outputting n as the result of the list. A singleton list n is the result. Otherwise, the result is n followed by f of nn. Nn is next number, let us say, where now we need to describe how to compute the next number. Okay, remember the procedure. You have a number, you extract the digits, arrange them in descending order, arrange them in ascending order, and subtract the second from the first. Okay, this is what you want to do. So now this f won't compile because next num has not been defined yet. Okay, so let's define next num. Its type should be integer arrow integer, int arrow int. By now the number has been sanitized. So, and extract digits is also a function that we have already written. So what should you do? You should extract all the digits, that will give you a list. You should sort it by descending order first, sort it by ascending order, subtract the first from the second or second from the first, and then you should convert it back to a number. Okay, so then so you need to go back from a list of integers to int, list to int, let's say. But this is very similar to something that we saw in the slides a few lectures earlier, string to number. You are given a string and you should convert it into a number. Here it is much simpler. You are given a list of ints and you want to convert it into a one int, and the way to do it is to do foldl with the function being accumulator digit goes to 10 times accumulator plus digit, and then the initial value of the accumulator is 0. Okay, that's it. Okay, good. So this is done. Now what is next num? Now we have all the ingredients in place. Okay, so we have next num is actually num1 minus num2, where num1 is list to int of now you need to sort the list by descending order. What is the list? So you need to have that list as well, the list of digits. So let's just say d is equal extract digits of n. Okay, you have d's and you need to sort d's by descending order and then apply list to int on it. And for this we use a, rather than write our own routine to do sorting by descending order, even though this is only 4 digits, we will just use something general that Haskell provides. If you import data.list, you will find that it has something called sort by. And sort by says, oh, give me a function which is of type A arrow ordering, give me a list of type list A, then I will produce a list of type list A which is the sorted order of the original list provided by this ordering. Okay, what is this ordering? We will figure it out. What is this type ordering? Okay, to begin with. So ordering is a type that has exactly 3 values. One value is called LT. It's a data. Its declaration you can imagine. Data ordering equals LT EQ GT. Okay, so all in capital. Okay, so okay, there are these 3 values that belong to ordering, and sort by uses an ordering relation on your input list to produce an output list of which is sorted according to that ordering. Okay, so what is a function that produces values of type ordering? It's called compare. Okay, let's just define. Okay, look at the type of compare. As long as A is an orderable type, it will take 2 values of type A and produce a value in ordering. Let's look at a few examples. Compare 5 6, let's say, is LT. Rather than saying true or false, it will give this value from ordering. Compare 6 5 is GT. Okay, so now if I want to sort something in ascending order, let's say if I just say sort, let's say 4, 5, 3, 6, 7, 8, 9, 1, 0. Okay, it will sort it in ascending order. If I want to sort it by descending order, or if I say sort by, I need to give a function which takes two values of type A and produces a value in the type ordering. So x, y, right? This is the same as saying sort. Okay, sort by, and you just say map xy to compare xy, and we know that there is a better way to do this, which is that sort by compare. Okay, 4, 2, 3, 5, 6, 7, 8, 9, 1, 0. Let's do this. Yeah. So this is the thing. So now, if I want to sort in the opposite direction, we will have to give the opposite values for each compare. If I compare x and y, if x is less than y, I should give GT as the answer. Okay, and the way to do that is to say compare yx suppose I take xy and compare y with x. So I'll flip the LT GT values, and if I do something like 2, 5, now really all what I'm checking is I'm checking whether 2 is greater than 5. Okay, let's just check 5 too. I'm checking whether 5 is greater than or equal to 2. Now this should return true for me. Okay, it says LT. Okay, it's not true, it says LT, but really what you're doing is you are using the opposite order. Okay, and an easier way to do this is to say flip compare, because remember that flip uses the same function and flips the order of the arguments, accepts the arguments in the wrong order. So flip compare 5, 2 will give you LT, flip compare 2, 5 will give you GT. Now if you use flip compare in sort by, then what it will do is it will carry out the whatever sorting algorithm it is, except that wherever the original thing made a decision when x was less than y, now this thing will make the same decision if x is greater than y. So in the end you will see that the whole order will be reversed. Let's see sort by flip compare. And let's even say 0 to 9 should give you the reverse order. Okay, so this is the thing about sort by. So let's go back here to the demo program. So num1 is list to int of sort by flip compare of ds, and to use this sort by I need to import data.list. So let me do that also. Okay, and num2 is list to int of sort ds, I should say, but I'll just say sort by compare ds. Right, so that is my next num, and this completes my whole program. Okay, so let's see if the program works correctly. Okay, so let's we have already checked, so let me reload the program. I have an error. What is the error? Parse error on input, where it says okay, so there shouldn't be any Okay, so let's fix the errors and yes, we are done. Okay, so now the program compiles. Let's try to check on 3000, which is what we tried earlier. Okay, so we get a value here 302997736354308783526174. So I leave it to you to check that this is actually the, actually one can check 8352 is what? What is the sorted order of descending sorted order of 8352? 8532 minus 2358, right? It is 6174. Okay, good. So there was something else which we tried which didn't give an answer for a long time, and what was that? That was yeah, we could try for various inputs. F of 4000, let's try. F of 40,000, if I try, it will say input is not of the right format. Okay, oh, it works. It shouldn't work, but it works. So why? Okay, so I've yeah, this is what I should say. Okay, so let's try it again. F of 40,000 should now give an error. Okay, so input is not of the proper format. F of 3000 should hopefully work the same way. Yes, it works the same way. F of 4000. You can have a lot of fun playing around with this. F of we tried something that seemed like it wouldn't terminate at the correct place. 5829, let's try. Yeah, this also terminates. Okay, no matter what, it all terminates. Okay, and this is a very nice feature. You see that every list seems to terminate at 6174. Indeed, it will always terminate at 6174. This number is called Kaprekar constant. The mathematician Kaprekar proved that no matter which 4-digit number with this property you start with, and if you keep on repeating this process, you will end at 6174. Okay, so that's a nice mathematical problem which you can verify using your Haskell program. Okay, and this was a program which I wanted to show you because this involves numbers, converting from numbers to some digits, and then doing something with those digits, converting back to number, doing something repeatedly. Okay, so things like that. So hopefully this was one interesting problem which tells you how to go about solving these problems. Okay, as you can see, this is not too non-trivial a problem, but you still have to put together various ingredients, and we did it all from scratch. Okay, rather than showing you one already solved solution and then discussing it, I just programmed this live. Okay, so that you get an idea of how to do these tasks by yourself. Okay, good. So here is another task which is just some this thing. I said that you can do some fun math puzzle kind of problems. You can also do some mundane problems, but even something mundane becomes slightly more fun if you put it in the context of sports. So this is some bookkeeping thing. So let's look at some thing like this. This is a whole list I have given. So this is a list of basketball scores. Okay, some particular team which I am following, it is the scores for that team. And notice that some of the games have H, some of the games have A. H means home games, A means away games. So these teams, these NBA teams throughout the season over 4 months or so, they play about 82 games, some of them in their home court and some of them they will visit the other team to play there. So these are home games and away games. There are no ties in basketball. You always, so either the first team wins or the second team wins. So I have a collection of game scores, let us say. So it's a very rudimentary game score. It just says who has, for my particular team, whether it's a home game for them or an away game, and what is the point scored by my team, what is the point scored by the opponent team. Okay, what is it that I want to do at the end of all this? I want somebody to be able to read all this and say, how many total home wins do I have? What is my home win-loss record? What is my away win-loss record? Okay, so this is the kind of thing that I want to do. So let's try to represent this problem once again as some data type. So at the very least, I've used some H and A there. HA equals either home or away. Okay, deriving show, let's say EQ show. Why not? Okay, and you can use data structures or you can just use type synonyms. Type win loss is just int, comma int. Yeah, I need to compile win loss records, but before that I need to say type score equals nothing but home away, comma a pair of integers. And win loss is this. Finally, I want to compile win loss records, but win loss records are home win loss and away win loss. So I'll say win loss is two pairs of integers. The first pair tells you how many home wins, how many home losses. Second pair tells you how many away wins, how many away losses. Okay. So yes, what is the function that I want to write? I want to write a function compile stats, okay, which should take a list of scores and produce a consolidated picture for me in terms of win loss. Okay, this is what I want. So how would I do this? Okay, not compile states, compile stats. Okay, now this problem, even though it looks like there is a lot of data floating around, the earlier problem had only numbers, but we had to work a little bit to represent the numbers, figure out how to extract the lists, etc. This problem actually, once you know your folds, this problem actually becomes trivial. Okay, because compile stats or I could even say fold L, fold R, doesn't matter, fold R bump. Okay, and I have an initial value of win loss, which is that 0 wins, 0 losses at home, 0 wins, 0 losses away. And then each time I read a score, I will use it to bump the existing accumulated score. Okay, that's it. Okay, where bump, I have the home away status and then score, the score of my own score and the opponent score. My score, opponent score. Okay, and then the other value is this win loss. Okay, so it will have home wins, home losses, away wins, away losses. Okay, this is my inputs. How do I bump it? Okay, so you could just say something like this. right? So you could just say existing win loss, my existing win loss record, which is a pair of pairs, and I have this, and what I can do is add win losses or bump win losses, whatever, I can call it whatever I want. Extract win loss status from, so in fact I should even for this for this I should just call it score. Okay, so I have a score, I have a win loss record currently. I should extract the win loss thing from the score, and then I should bump the win losses column by the win losses statistics by the extracted win loss from the score. So now this whole point is about the bump WL and extract WL. So let's look at that. Extract WL. Okay, so how do you determine whether it's a home win or an away win? So let's see, what do I want to produce here? I want to produce just a pair of pairs, but the inside thing will only contain 0, 1 values. Let me explain what I mean by this. Okay, so if yeah, we can use pattern matching, right? So the first part of the thing could be a home, it could be a home game. Then what should you do? If my score is greater than opponent score, then okay, else okay, similarly this might not be the most elegant way to do it, but this is one way to do it. Okay, if it's an away game, then once again, but the so you're just stating whether it's a home win or a home loss or an away win or an away loss. Okay, so that's all you're maintaining. So here this should be 0, 0, this should be 1, 0, and once again here this should be 0, 0, and that should be 0, 1. Okay, now we've done this. Now what is the bump win loss? So this is a situation where you have A1, B1, C1, D1, and an A2, B2, C2, D2. And what you do is bump win loss of A1, B1, C1, D1, A2, B2, C2, D2 is nothing but A1 plus A2, B1 plus B2, and on this side C1 plus C2, D1 plus D2. Okay, so that's it. So this is the complete program, and this is just fold R. Okay, so I mean, of course, there are some parts which are like you need to do some basic, determine what is a win, what is a loss. My score is more than my opponent's score, it's a win, otherwise it's a loss. But otherwise, it's just fits some basic pattern, and not how this fold R is such a powerful thing. Okay, so that's basically it. Okay, so let's test it on some inputs. Let's first check if it compiles. Yeah, thankfully it compiles. I have some input here in this file called counts.in, which I will just copy paste onto GACI. I'll say scores equals no, okay. It says paste as one line. I'll do that. Okay, that's one. Why is there? I don't know. Scores. Okay, yes, good. So there are lots of things that have been pasted. Okay, so there are 37 lines. I think 35. So look at length of scores. Okay, yeah, there are 35 scores, and we can actually check compile stats. We can say. Right, that's it. Okay, so you can even check that it all works out correctly, right? Because 11 plus 6 is 17, 12 plus 6 is 18, 17 plus 18 is 35. So there are 35 games. The home record is 11.6, the away record is 12.6. Now you can actually, once you know Haskell, you can also pick up your favorite game and write some small programs to compile statistics, etc. In this manner. This is not a great application or anything. I'm just doing this to show that you can do a variety of tasks with Haskell. We'll actually revisit this example where we show how you can read these scores from a file later when we talk about input output, and then output some more elaborate stats into some file, etc. Okay, thank you. So I'll stop this lecture now.